This is the start of the ARM Server Mini Summit, and the first session we're going to be talking about UEFI. Now this is, for those of you who have been at Connect, you'll be familiar with this, but this is going to be run very much as an engineering session. I don't have a set of slides. I'm not going to be presenting current state or any of that, but what we are going to be talking about is what needs to be done and how we're going to get there. And this is intended to be interactive. We want to talk about what problems need to be solved, how we're going to solve it, and what the work items are going to be from here until the next Connect. So to start with, what I'd like to suggest is anyone who is particularly interested in this topic, move over here, come sit down over in this section. Yeah. Hello, Ryan. So that we can actually talk and not be shouting across the room. So, all right. So I think to begin with, for those of you who don't know us, I'll get us all to do a brief introduction of those of us who are involved with the UEFI work. Give people a moment to sit down. Yes. Yeah. So my name is Grant Likely. I am the tech lead for the UEFI team here at Linaro. I'm going to moderate for this session. Ryan?
Hi, I'm Ryan Harkin, the tech lead for the ARM landing team, but I'm also the UEFI maintainer for the Linaro tree at the moment. So I think most of the work that's being sort of, well, I suppose at the moment, most of the work that's been going on in Linaro has been sort of involving me at least. And because I was maintaining the tree and the platforms and things like that, then I think I was sort of, for a while I was the only guy that was doing UEFI work in Linaro. But I think, as you can see now, the team has expanded somewhat. And it's not just us four guys up here as well as Grant. There's a few of us. So yeah. That's me. I'm the tree maintainer at the moment.
I'm Leif Lindholm. I seconded into Linaro from ARM. I'm working currently on a port of Grub to the ARM UEFI 32-bit platform, and we'll be moving on to Grub on 64-bit ARM platforms later on, as well as various other UEFI tasks.
I'm Reese Pollock. I'm an assignee from Texas Instruments. I'm working on bringing network boot to UEFI.
Yeah. I'm Ronnie. I am an assignee from Samsung. So my current areas of focus is eMMC, SATA on UEFI, including hypervisor support on UEFI.
Anmar, introduce yourself.
Hi, I'm Anmar. I'm the UEFI project manager in LEG.
And Andrea doesn't want an introduction. We got to keep going. Okay, so what we want to talk about is what it is that we're doing and what the work that is going on with UEFI, how we're going to get there, what exactly problem we're going to solve. I'm going to spend about 5 minutes talking about what we're trying to do before we then get into the technical details of exactly how it's going to work. So the first part is, why are we even doing UEFI? Why is UEFI better than U-boot, and what is the problems that we're trying to solve? Because no one's going to be buying equipment because it runs UEFI. They're going to be buying equipment because it solves problems. UEFI happens to be a part of the puzzle that gets us through from a paperweight piece of hardware that sits on a desk or in a data center to something that will actually do useful work. And part of the problem that we're trying to solve is how do we build the firmware of a system so that any of the operating system vendors are able to produce a distribution that will install and run on commodity hardware without having to go through the exercise of doing a board port every single time. x86, this is taken for granted. ARM, we've not been very good at this historically. So that's the problem that we're trying to solve. But that's a very broad description of the problem. And to try to tackle that problem in its entirety, we're not going to do it. So we've tried to condense it down to some very specific use cases that, from us in this group, look to be the problems that are the most important to solve in order for ARM servers to be actually useful and do well in the market. So the two use cases that we see as the most important is, first and foremost, being able to network boot these things. The direction we've gotten so far is that the ARM servers, a vast majority of them are going to be in these hyperscale data center installations where it's really important to be able to get the power, once the power is on, to be able to push from the network using a tool like Cobbler or Mass, commission these systems, get them into a booting environment that will then go and boot the whatever operating system image or whatever kernel the owner of those systems wants to run. To do that, we need to do things very much similar to what x86 has done. So that means bring up DHCP, get some configuration off the network off DHCP, load some kind of bootloader with TF2 off the network, and then go in and boot the kernel. The other major use case that we see as being important is the traditional computer, disk, operating system installed to disk, we're booting off disk. The reason we're using UEFI, one of the reasons we're using UEFI is it's already established in the x86 world. There's really no point in having meaningless differentiation or something different just for the sake of being different. And UEFI has got very good processes around it already that has standardized what the firmware should look like. So that's the problem that we're trying to solve. A third use case that we are eventually going to need to get to, but we haven't got to yet, is how do we then boot virtualized machines that are on that are then running? Do we then have another instance of UEFI that's running on the guest in order to load a kernel? But we've not seen that one as a priority use case, simply because in all of the virtualization scenarios, the hypervisor application is able to boot a kernel directly. We don't have to go through firmware in the same way that we do when we're doing booting the bare metal. So that's kind of and I want to start there, is those are the use cases that we see. And I'd like to have feedback of, does that make sense? Is that the problems that you out here are seeing and want to need to be solving?
Are you saying that in the case of a guest booting that you don't need to provide the same environment? What are you saying in terms of guest booting?
I'm saying that with guest booting, when you have a machine already commissioned running an operating system, you can then run KVM and provide it with a kernel image. So right from first instruction, we can be into the kernel. Okay, sorry, the question was, John Masters was asking, am I saying that we don't need to have the same firmware environment in the guest systems? And I'm saying what we've seen so far is that it's not priority to do that, because there's also the solution of booting the kernel directly from the KVM or from the Zen application. It's not that that isn't a valid use case and that it wouldn't be valuable to have UEFI running in the guest. It's just not priority for us right now. Now, I should put this caveat on. Anything that we're saying here, Linaro, the enterprise group, has a steering committee, and the steering committee makes the decisions on what we're actually working on. But we've taken a first shot at this, at what we think needs to be done. Want to make sure that the assumptions and the decisions and the things that we're looking at actually make sense. So,
I think that for this guest, thank you, Brett. when it comes to booting a guest, I think one of the important thing is uniformity. I mean, we're adopting UEFI just for this, mainly for the sake of having a uniform pre-boot protocol environment. When you're commissioning a guest, you basically don't want to know if it's a virtual machine or bare hardware. You probably want to commission it in the same way you're starting a real machine. So,
So I think the question is different, and we're getting a little bit bogged down in the virtualization question. It's like, are the priorities they've set themselves right now, are they the right ones? And I think from my perspective, the answer is yes. I mean, it's all about covering our basics first, right, and then working ourselves up. Now, I do agree from a virtualized and a physicalized environment, you want to have exactly the same thing. You want to have as much commonality as possible, because otherwise you just get fragmentation in the software stack. But from my point of view, you're working on exactly the right things.
Just to out there, I'm not disagreeing, and I think this is all fine, but in the longer term, where I want us to get to is not as the assumption that we're going to boot guests using any different contract than what we would use to boot bare metal. And one other thing I wanted to ask was about the, you guys had mentioned yesterday about, I know this is off in the weeds with virtualization, we can come to it later, but the change in the proposed change to the UEFI booting protocol for what level you enter at, privilege level on AH32, and then the exception level stuff on AH64 is already standardized, but the privilege level stuff we should discuss at some point.
That's actually one of the things that I've got for the agenda today, is we want to talk about how we're going to do some of those things. So having said, kind of, this is the broad stroke of what we want to do. There's some technical areas that are either difficult, or we've made some decisions on where we think we should go that also want some feedback on. So the first thing is, where it comes to how we've been trying to solve this problem, our assumption, or the way that we see things, is we need to, once UEFI comes up, we assume that we don't want UEFI booting the kernel directly. Oh, where was the? There's Greg. Okay. We assume that most users are not going to want to boot the kernel directly. Because if you're booting the kernel directly, then you need to be able to make sure that the kernel is able to then get its configuration or any other things that you get off the net boot. And it's not what is currently being used by Cobbler or Mass for commissioning systems. Okay. Yes, we have many UEFI bootloaders. Because we're going to use Grub. We're not changing. That's the plan. Is we're going to use. We're not going to invent something new. Not on ARM yet. Well, I mean, you look at Grub, it's a lot more than that if you're booting from disk. Oh. Okay, well, then I want some feedback on that, because what we've... Uh-huh. Which is exactly what we, I mean, but there's still that, Gummy Boot is still a bootloader. There's still a shim that's in there that figures out what needs to do. I think we're getting bogged down on semantics because we're talking about the same thing. We're not. It's not done until it works. Okay.
Explain to Greg that the Tiano, the point is you're quoting Tiano as a reference to.
Okay. All right. So,
might not be
okay, fair point. So John just said that it's probably not clear on what exactly we're doing. The project that we're working on is, we're using Tianocore, and we're using it, so that's ported. It is running, I mean, Ronnie, I'll let you talk in a few minutes on stuff. Or Ryan, do you want to say kind of where things are at with Tianocore?
Well, I suppose we've taken the upstream Tianocore and we've provided various different board support packages around that. So we're using pretty much core Tianocore code up from the upstream, and that's where we boot from. We're using a BDS that's specific to ARM rather than using a sort of central BDS.
I guess
but
that's
otherwise,
one thing that's fair to point out, that there's a surprising amount of Tianocore that is actually stuck underneath the Intel platforms. That should really be generic, and some of that will need to work on porting across to ARM, and maybe some of it we need to work on actually breaking out and making it generic and able to be, in order to be able to use it on ARM.
yeah, sure. And so basically what we have at the moment is certainly an ARM specific port of Tianocore, and we're booting the upstream ARM version of Tianocore at the moment on various platforms. Ronnie supports one of them on Samsung side, and there's the Versta Express platforms, there's TI's Panda board and Beagle board. It's all in the upstream tree. But yeah, the idea of like gummy boot, for example, I mean, I have no visibility of that. Perhaps it just works, perhaps it doesn't on ARM, I don't know.
No, that's the problem. So, yeah, go ahead, Leif. Yeah.
I mean, since I started working with Grub, I've come to realize it's yet another operating system, just like UEFI. It has dynamic linker in it, right?
UEFI doesn't need that.
No, but Grub does.
No, so don't use Grub.
That's a different question.
Well, okay, let me make that question. Why do you think UEFI needs Grub?
Why do I think UEFI needs Grub? There's a couple of practical benefits. Things like Grub has support for various different file systems that you don't then need to have inside your firmware in order to be able to boot from different file systems. I guess the real reason is it's a sort of useful abstraction layer for the distros to not have to worry too much about what's underlying. You don't have to know exactly what you're going to boot on every single platform your operating system's running on, because Grub will sort of work as the abstraction layer.
All right, I'm gonna, you and I will talk later, but I think the thing that needs to be made clear in kind of what we're doing is this is an engineering project where we've got 2 points. We've got bare metal, turn the board on, and we've got boot the kernel running RHEL or Ubuntu or some other or Zen or some other distribution, and it'd be the same the whole way across. And so what we've done is we've kind of taken a point from the beginning to the end, and we've looked at what are all the holes that we have right now. Well, UEFI, Tianocore, but we need to make it work. And the distributions are using Grub, so Grub, we'll use that there, but we need to make it work. And then we're into the kernel. So that's why we're using Grub, is because that's what we've heard, is that that's what the distributions are using now, and that's the place that we should be spending our engineering effort. However, in saying that, there is absolutely no intention to mandate that thou shalt use Grub to boot these things, because there's going to be Gummy Boot, or there's going to be EFI Linux, or there's going to be any of the other solutions that people are going to go and do, and it's going to be awesome. But it doesn't get us to the point that for this engineering project, it doesn't get us to where we need to be yet. Does that make sense? We'll talk later. So, the plan is, as Ryan's talked about UEFI, and we've got Grub 2 working, and what we've heard so far is that Grub 2 makes sense for both if we're booting off disk, because I mean that all works, but also to do the same thing for booting off network and uses the Grub 2 configuration. And so for Pixie booting, it's not really PXE because it's not the pre-boot execution environment of x86, but it's a UEFI binary. The grub2, load that, and grub2 should have all the, using the UEFI networking facilities to get the kernel that it needs. So again, we should be using all code that exists and is working. Leif, do you want to talk about the status of grub2 and where things are at?
So, I mean, I sent the first time I looked at grub, I started with a port to U-boot using the U-boot API. And that's been working for a few months now, but for various contractual reasons with regards to the FSF and contribution agreements, they haven't been formally submitted as a patch yet. I'm hoping that's going to happen next week, probably. Since then, I've been working on grub on UEFI, and that's now up and running with file system and the dynamic linker and everything on UEFI 32-bit. I haven't so far even seen a Linux kernel crash, but I'm hoping to get there today. I could add that what I've done with regards to device trees is I've just implemented a new grub command that lets you load a DTB off a file system.
Okay, so I guess that covers the second layer of what we're going to be working on, and now we can go down and talk about the actual details of the technical problems that need to be solved. Bill?
Before you get into the technical, can you talk about the managerial? Where do we come out with deciding which parts go to Tianocore upstream? Are we going to have a multi-vendor implementation in Linaro? What about the Git hosting and how that's going to work?
There is, can't go into the detail of exactly how the maintainership structure is going to work because we haven't figured, it's still in flux and trying to figure out exactly how it's going to work. But what we are planning to do is have, one of the problems that we've been running into is that the Tianocore upstream project doesn't want any board support. So we need to put that board support somewhere, and the plan is to have a tree use exactly the same rules as Tianocore, exactly the same licensing, take contributions from all comers for board support. And that will be in a separate tree that tracks the Tianocore upstream tree. The maintainer for the ARM stuff on UEFI is Olivier Martin, and he's going to continue doing that. Exactly how the patches are going to flow and how we get that so that we've got a nice long-lived branch that people can depend on is still for trying to get that worked out. Well, it's happening. Yes. Yes, and I think, yeah, we've good.
I think the answer to your question is the end of March we should have something written down that we can share with the world.
All right, any other questions on just the pieces that we're working on with UEFI and grub2? Network status.
We've been fighting a little bit of an interesting problem in bringing this up in that the reference boards, most of the reference boards we have, for example, the Arndale from Samsung, the network interface is connected via USB, which requires having a USB host stack that's fully functional. What we've ended up resorting to is the fast model, and we think we have a driver that ARM has worked on that isn't released yet. That will drive that. So we're hoping to have something where we can download a file this week. I won't promise that, but that's the intent.
So this has been suggested before, but why not use QEMU?
Why not use QEMU? You mean? Where is Peter? Is Peter in the room? Peter Medell? Okay.
We looked down that path, and the point came back that this would be an interesting and valuable effort to make UEFI boot on QEMU. But at the moment, it doesn't, because both QEMU does not support the all the functionality that the current systems are expecting, and it just basically the faster path is to go with the fast model. But the intent, of course, is to provide this across other platforms. I've got, for example, I've got the BeagleBone from TI, which is a very inexpensive, has a non-USB Ethernet. We don't have UEFI running on it yet, but that's one of the options. And there's also work that you've done where we're getting close to being able to use the host USB stack to be able to get access to the network interfaces on the Arndale and that type of thing. So there's a number of progressions on that, but QEMU just didn't end up being the short path.
Oh, go ahead.
Yeah, enabling PXC in the Arndale is a slightly longer path because you need to enable USB first, which is currently working right now. Then we need to enable the Ethernet on top of that. And the other problem is the PXC methodology also, which needs to be established on the UEFI. So one method which has been suggested is that we'll try to run PXC on top of Grub, which will actually call the UEFI through UEFI, which will access the Ethernet and load the Z image from the network or U image.
So with I also just want to go back to the maintenance with the stuff that like Reese is working on right now. Pretty much all of that is there except for the Ethernet driver. But Ryan has been maintaining a UEFI next tree that contains pretty much all the work that has been done so far, and all of the for patches and contributions. UEFI, which mailing list should people be looking for?
It's the boot architecture mailing list we use for all of our submissions. So yeah, just the standard boot architecture one that you set up originally. For general boot architecture, we take all of our patches through there.
Okay, so that's the boot architecture list. We need to check and make sure that, I don't know if that list is publicized. Anyway, is it on the wiki pages?
On the wiki
okay, so we're good. Okay. I guess the next thing that we can move on to is you want to talk. Oh.
Start in secure or non-secure mode. The problem we have is errata workarounds with single Z image so far. So even we don't talk openly about it, it's a reality.
Ryan, do you want to talk about this?
Basically, we're taking the support from ARM directly, but at the moment, there's not any of that support in there. We're just effectively booting a Z image, but the support that's coming from ARM in the near future will provide a secure OS implementation within UEFI. So, yeah, it's going to come, but it is not there at the moment. But we're going to be booting, because UEFI is already split into two binaries. One is basically the whole Tianocore, the whole pre-Tianocore side of things, which boots the SEC stuff, sets up trust zone and things like that, and then that binary then boots the regular UEFI binary. And so, yeah, and we're going to get an implementation for TC2 in the near future that will be booting in a secure OS sort of way, but it's not there yet. I don't have visibility at the moment. So TC2 is a platform from ARM. It's a Versatile Express core tile. So Versatile Express being a platform, he's not listening anyway, so it doesn't matter. So yeah, but it's a Versatile Express platform with a core tile on, and the core tile is called TC2. That's the big little tile from ARM. and that's so yeah, when we talk about TC2, but it provides all of the secure features, and it has trust zone in there and things like that. And we're not at the moment booting using a secure OS sort of stack, but we will be in the near future.
Hi, this is Dan Handley from ARM. So, yeah, you're right. It's not a full trusted OS environment with a trusted execution environment and global platform and all that stuff. But it's a basic example, trusted firmware that loads before the main UEFI binary. It's just a bare metal example code to set up the trust zone environment.
Interface, right, of the ACPI, the power management stuff that's happening in ACM?
No, not really. It's just a bare metal binary which sets up the secure world and then passes into non-secure world.
Can I add one side comment to that? Yeah, just one other side comment, because the reason Catalin raised that was for errata workaround setup, right? So we had a discussion recently on an industry standardization call where we were discussing coming up with a list of errata workarounds we've had to do in Linux previously. So I need to sync with Rob on that and provide a list of examples in you. And then the idea is that because on some of these platforms, take the Calzada design as an example, you don't have the ability to write to undocumented diagnostic registers from Linux that you might want to, and so you have to do some errata setup ahead of time. So we need to provide a list of examples to ARM and have a standardized set of secure world calls that can be set up for doing that. But that's something I think that gets done separately. So sorry.
That's true for every platform with virtualization.
Right.
That's true for every platform with virtualization.
So it's it also, yeah, it gets more complex as well with once we've got the secure world in there. I mean, if we're looking at UEFI, the UEFI, the core UEFI proper really only runs at one level. And so, all the setup code that goes through, I mean, we've got sample stuff, but there's nothing in what we've done so far that really defines what needs to be running where. And I mean, that's the stuff, as John has said, that we've been talking about in the ARM server and trying to figure out what that's supposed to exactly look like and how to draw the boundaries. One of the things that has been a topic that's come up over and over is how do we handle, how do we make sure that the secure world doesn't end up having the bad behavior that SMM has had, or SMI has had traditionally in x86, where the current, the processor will go away for hundreds of milliseconds. Well, we have to have, but that's UEFI runtime services, which is not the same thing. We have to have it, but it's not the same thing, and it's another problem. So, I mean, yes, UEFI runtime services, that's one of the things that we are going to, that is on the list of things that have to be there. The primary reason why we feel we need to do runtime services is so that the installed operating system can write to UEFI variables. And so far, that's the only reason that I've heard, only really compelling reason I've heard for doing UEFI runtime services. Everything else is supposed to be shut down. Boot services are supposed to be turned off. But trust zone is something else because it's in a separate address space and it's, we need it. Okay, yeah, it's a can of worms. So we'll talk about that one later.
We've had lots of conversations about what the entry mode to the kernel is. I think we should also have recommendations of what the entry mode to UEFI is and what mode UEFI should run in, and that's also defining the runtime services interface.
Yeah, actually that's a big question. Go ahead, John.
So
So this is a concern I have, because I was involved in the unbinding sub-team for 64-bit EFI, and that's why I insisted that we enter at EL2, which is the hypervisor level, so that we can always install a hypervisor and then drop exception level if we want to. The problem is on 32-bit, the way the standard is currently defined, unless I'm completely smoking crack today, you actually you're not at that privilege level. It's called a privilege level on 32-bit. You're not at that level. And so my understanding from a side comment I heard yesterday that I didn't know about was that you guys want to propose a different entry mechanism for 32-bit. Can you detail what that is?
Okay, now the disclaimer on this is a hour-long discussion that happened yesterday with the Zen folks, or no, the Zen folks weren't there, but to try and figure out what we want for, what entry mode we want. And for the kernel, for KVM, we really want to have the kernel entry point at the higher supervisor level. But how do we do that? And
we discussed this in the unbinding team, and we had Microsoft on the call, we had others on the call, and we said we'd love to change the exception. We'd love to change the privilege level we enter at, because that would solve this problem.
Yeah,
sure. Sorry, we had this whole conversation in the unbinding subteam when we had the other operating system vendors there, and I said, is there a way to change the spec so that we can enter at a suitable privilege level to install a hypervisor? And the feedback was, no, we can't go back in time and change the standard now because people have built systems. So that was shot down. So I know ahead of time, if that's raised formally, that will be shot down. So we need another answer.
No, I mean, I was in those same discussions. I mean, I know exactly what you're talking about. The issue was exactly, we cannot break working systems, and that has not changed, and that is not the plan. We've talked about the runtime services. No one's done it. No one's actually done the work to figure out how we're going to get into hypervisor mode, and that was the discussion yesterday: is what are we going to do? Because we got to do it. A magic call is one way to do it. Another way to do it is to have UEFI, to have a mode that the bootloader has to specifically request to get into hypervisor mode. So existing operating systems, nothing's broken. But we have the option of saying, no, kick me in the higher privilege level. But no. I mean, but we don't have a proposal in the ARM binding subteam. Yes, we do. There was a proposal from ARM with several solutions that we got people to vote on. Okay, then I missed that because I was looking for that. Can you forward that to me? Okay. Okay. All right.
Sorry, that's what I was.
Okay. And I think we are just about out of time. Yeah, we're at 9:48. Any other questions that you want to talk about?
How do we keep everybody in the loop so that next time when we're here, we all kind of already know everything that's going on? What's the best way to make sure that we...
Anmar? Or...
Yeah, I mean, technically what we can do is we can send emails to the root architecture mailing list. There could be a wiki page that we can dedicate to always keep up to date. And there's, if you guys have specific needs, we can meet those later, but I think those are good starting points.
I just want, so not for me, but it's for like somebody else in here.
Yeah, I guess the question was, how do we keep all these people in this room aware of what's happening on UEFI? Mailing list and wiki is the best, Andrea.
There's the Linaro-Enterprise IRC channel. There's the Linaro-Enterprise mailing list, the wiki with the UEFI specific page. So follow the IRC channel and subscribe to the mailing list where you will get the links to the weekly reports.
Right. Bill?
So I don't want to sound discouraging, but I think on a code execution strategy, we're making progress, right? We're getting some stuff running. I'm concerned that on an architectural level, we're not making progress. These are the same open questions we had in Copenhagen, and we need to be making progress. I would have expected some of these open issues to have been closed by now. So I think we need a little bit more structure on how we get these architectural items closed.
All right, any other questions, comments? All right, thank you very much.